All right, so this is now, in this example, we're going to be looking at minimum cut and maximum flow. So over here in our description over here is that if you can find the minimum cut capacity, meaning wherever you can cut or select edges, okay, multiple edges where you are literally completely blocking the source side towards the sink side, all right, so where the source of the, say, water flow gets to T, if you can completely sever that, you've got the sink side and then you've got the source side and then the sink side. What they're saying is that the minimum cut capacity, so capacity means the amount of flow that can go through those edges that you're selecting, and how you select it is by the cuts. The minimum capacity is the maximum flow, because remember we said that the maximum flow is dependent on the minimum value that's there. So in this example here, you can see that what are the possibilities of severing from S to get to T? What are some of the things I can do? Which edges can I cut to completely sever it? Well, I can do this cut. Okay, so C1. C1 cuts those two edges. So I've got two edges. I've got 1 and 2. Those two are completely separated. So if you think about it, it kind of looks like that. And this is S. And that way it doesn't get to T. So I'm still missing A and C. So it gets cut off by this line. You see what I mean? So then the flow in the first one here is in this line here, the source, from source to sink, this side has 8 and then out here has 11. Whilst on this side, whatever's on this side, I'm not interested in. I'm only interested in from the sink side to the flow, the source side to the sink side. I'm not interested in this side here. Okay, but anything that seems like it's, even if I had a line that comes this way, but if the flow direction, if the arrow shows that it's coming from the sink, I don't include that edge either. Okay, so I'll show you an example soon. But what we can see is in my first cut 1, the two edges I've selected, SA and SC, so S to A and plus SC, these two have a total capacity now of 8 plus 11, which gives me 19. Okay, now remember, I know that if I can find the minimum capacity through these cuts, then that will be the maximum flow for this problem. Okay, so remember in our previous examples, we were trying to find maximum flow by inspection. But when there are more vertices and there are more edges, it makes it harder to do. So we use cuts to allow us to sort of see what the maximum flow would be. So I've just done the first cut and I've selected these two edges. But it could have been not those two edges. It could have been, say, I could have done maybe this edge, this edge, this edge, and this edge as an example. Or I can do, say, I can cut 8, 3, and so those 3 I could have done. Do you see what I'm doing? So it didn't have to just be 8 and 11, but what if I did 8, 3, and 1? Yeah? So that completely separates the source side to the sink side. And if I did that, well, you can see that the flow at this point, I've got a flow of 1. Here, it's still going out. So from the source to the sink, I've got 3. And then from here out, I've still got 8. So you can see that in cut number 2 there, I would get, what did I do there? That was C to B. So I'll just write it out. So I've got S to A still included, C to B is still included, and C to T is still included, because they're all coming from the source to the sink, and that's 8 plus 3 plus 1, which gives me a total of 12. Okay, so that's one way of doing it. And let's say what else can I cut as well? So I can now try, say I cut so those I chose 3 edges there. I could have done another one. I could have done, say, instead of SA, maybe I'll do A to T. I cut that one out, and I cut out B and 11. Okay, see what I'm doing there? So this could be cut 3. Now if I did that, Okay, cut 3. So what does cut 3 look like? Cut 3 suggests that I have now included, I'm looking at S to C, that is still from sink, from the sink out. Sorry, not the sink, the source coming out, that can be included. This one I can't include. Okay, so A to B I can't because the source is clear, the arrow is pointing that it's going this way. So I wouldn't include B to A. So that's not included. But then the other edge that I've chosen is A to T, that is in the direction from source to sink. So I'll be including the 5. So here I would then say, all right, SC plus, in this case, A to T. Note that you don't include A to B in that case. Okay, and so this gives me now S to C is 11 plus A to T is 3, so that gives me a total of 14 for that cut. All right, so you got to do all these possible cuts and you're trying to find the minimum capacity. All right, so I did 3 cuts there. Let's do another one. Instead of, I could cut AT to separate it, I could cut AB, I could cut maybe CB, and I can cut CT directly like that. So this is, say, C4 now, my cut 4. If I did it that way, what can be included here? So we can see that from C to B is coming from the source to the sink as well. So CT is included as well. So CB, CT, so I should write this down in red. CB, CT, where else is there? I can see that AB again is getting cut, but that's again from the sink side towards the source side. So no, we're not going to include AB. But from A to T again, we can. So that means in this particular example, CB, which was 3, CT, which was 1, and then AT, which was 3. So that gives me a total of 7 as my capacity. Okay, so that's looking pretty desirable there. 7's a pretty low number there. And then what else can I do? I can also try cutting. So I've done down. What else am I missing? I could have done maybe, not sure if I've done this cut before. So I'm cutting 1, 2, 3, 4 edges that direction. Okay, so let's have a look at this one. Which ones would I be able to include? I can include S to T, S to C. I can include B to T, okay? And I can include A to T, but in this particular special case here, notice I can't include C to B, even though technically it feels like it's meant to be from source, source to sink, right? But notice, because of the way I've cut it, right, where I've cut it, this side here is the sink. And then where C is now, this point is actually in the sink side. So the sink side comes out and it goes that way. So that I can't include that. So that's why the only ones I can include now would have to be S to C. So I'm going to do, this is called cut 5. So cut 5, I can include S to C plus, I can't do C to B this time because C is in the other region. Think of it like you're splitting it up into 2 sections. You've got this top half and you've got this bottom half. So even though the arrow is correct, the point or the vertex is in the wrong position. So that's why I can only include B to T. Okay, so in all of that, I can still do B to T and I can do A to T. And that gives me a total capacity of 11 plus 5, B to T, plus A to T, which is 3. That's 16, 19 there. Okay, and what else haven't I chosen? Which other pairs to completely sever this flow? I know that one's another one that I haven't done. So that's that's 3, 5, and 1, isn't it? Because they're all coming from the sink. So 3, 5, and 1. So I'm going to write that now. So C6 is 3, 5, and 1. Notice that this is only taking me longer because I'm doing this by explaining to you as I'm doing it. So A to T and then C to T. But technically, you can do it by inspection as well. Okay, so B to T, was 5, and then A to T is 3, and then C to T is 1. So that's 9 there. All right, let's see. Can I get any other cuts there? I feel like I've chosen them all. I mean, I can try to sever it again. If I sever this one, that's now 1. Yeah, I've done that one already. C to T. Yep, I've done that one. Interesting. Yep, so I think that's all. So the best one of them all is this 7. So therefore, my maximum flow, therefore max flow is 7. Okay, so the minimum cut, that's what they mean by minimum cut. Essentially, they're saying minimum cut capacity is based on that will tell you the maximum flow that you can get. So essentially CB plus CT plus AT. So which direction was that? CB plus AT. So this one. CB, AT, and CT. So it looks like I may be doing a cut that looks like this then. Whoops. Like that. So that must have been the cut. And it's saying that that's where the maximum flows would be. So let's see if this is true. If we were to find the maximum flow that you can get, is it really 7? We can actually calculate and say, well, let's think about it. 11 comes in to this point and we're looking at flow, but this only allows 1, so we get 1. So only 1 can go through. And then if I had to go through, say, this side here, 3. If I had 3, well then 3 can only go here, so that means 3 is down that route there. And then if I go up here, that's 8, but then again, this only takes a maximum of 3. So yes, that is true. My maximum flow is 7. Which is interesting, isn't it? I guess you could just look at it and find the maximum flow by inspection, but I guess when it gets harder, maybe the cuts will be more useful. But that's how you do that problem with cuts.